All right, in this section we're going to be looking at solving quadratic equations using the quadratic formula, and also we're going to be looking at factoring as well. So we have looked at how to take a quadratic equation that is in standard form, which is what this is called right here, standard form, and we have done completing the square and put our equation into vertex form. We have done this in the previous section, and so what I want to do from here is say, what if this equation is equal to 0 and we want to solve for x? Well, if we're going to solve for x, that means we need to isolate the x and move stuff all the way over to the other side of our equation. So our x value is right here. The first thing that we're going to move is going to be this fraction over here, because you always move your addition and subtraction stuff first. So we move that over to the other side of our equation. By adding it, that makes it a positive b squared minus 4ac over 4a. All right, so the next thing we're going to move is going to be this a value right here. And we move it over to the other side by dividing it, keeping in mind that dividing is the same thing as multiplying by 1 over that number. And it's probably easier to think about it this way when you already have a fraction over here, so that in your denominator you're going to end up with 4a squared. So the next thing that we're going to need to get rid of is going to be our exponent. And so we're going to get rid of the 2 up here. We get rid of it by taking the square root of both sides of our equation. Remember that when you take the square root when solving an equation, you put a plus or minus in front of that square root. So we have the square root of the numerator over the square root of the denominator, which actually comes out evenly to be 2a, because 2a times 2a gives you 4a squared. All right, so now we're going to move the b over 2a to the other side by subtracting it. That's going to give us negative b over 2a plus or minus the square root. And since both of our fractions here have the same denominator, we can combine these together into one fraction, with the numerator being negative b plus or minus the square root b squared minus 4ac all over 2a. And this is what x would equal, or in other words, that's the value of x that would make this equation equal to 0. That also would be considered graphically to be the zeros or roots of your function. Now within this function, or within this formula rather, we have this part underneath the square root, this b squared minus 4ac. This has a name for it, and it is called the discriminant. What the discriminant is used for is determining how many of each type of roots you are going to have. You see, if this number underneath the radical symbol here, if this number is a positive value, then you're going to be having the square root of some number, and the square root of that number is a real number. And you got the plus or minus, which means if b squared minus 4ac is positive or greater than 0, then you are going to have two real roots to your equation. If your b squared minus 4ac is equal to 0, you are going to have one real root. Reason being is if you think about if this value underneath the square root comes out to a 0, you don't really need the plus or minus because 0 does not have a positive or negative value to it. It's just 0. So that's why you have one real root. And that root would be negative b over 2a because this part would all be 0. And then lastly, if b squared minus 4ac is less than 0, meaning it's a negative value underneath the radical, then you're going to have two non-real complex roots or imaginary roots. All right, so make sure that you know the difference between those three things. All right, so let's take a look at this first problem here. We have y is equal to x squared minus 9x minus 22. And if you think about different ways, we're going to be setting this equal to 0, different ways that we could solve this. One way to solve this would actually be by factoring, where this would be x minus 11 times x plus 2. Now remember, there's multiplication in between here, and we are multiplying this value times this value. If you are multiplying two things together and your answer comes out to be 0, that means one of these two things would have to be 0. So the value of x that makes this equal to 0 would be positive 11. And the value of x that makes this equal to 0 would be negative 2. Now the way that you can also think about that is that if you take each factor, set it equal to 0, and then solve for x, that would give you your two solutions right here. All right, so now we're going to be looking at this using the quadratic formula. Using the quadratic formula, the a value is 1. That's the number in front of the x squared, or the coefficient. The b value is the number in front of the x, right here, which is negative 9. And the c value is the constant on the end, which is negative 22. All right, so the first thing I want y'all to do is get used to just creating a template every time you do quadratic formula. And the template is going to have parentheses everywhere that you have either an A, a B, or a C. All right, so this is negative B plus or minus b squared minus 4ac over 2a. All right, so now we come back and we insert what those values are. All right, so negative b, that would be a negative 9. B squared, that's a negative 9 squared. 4ac over 2a. Now it's a matter of simplifying this thing. All right, so negative 9 becomes a positive 9, plus or minus the square root. Negative 9 squared is 81. And then negative 4 times positive 1 is negative 4, times negative 22 is positive 88, over 2 times 1, which is 2. All right, so now we come down to 9 plus or minus the square root of 169. the square root of 169 comes out evenly to be 13. Now, if this simplifies so that you end up getting rid of your radical altogether because this comes out evenly, then you need to go ahead and do the arithmetic here and get your two answers. 9 plus 13 is 22, divided by 2 is 11, and 9 minus 13 is negative 4, divided by 2 is negative 2. All right, so those are your two answers that we end up with using the quadratic formula, and these were the two answers we ended up using factoring. Now, if you notice, factoring is probably a lot shorter and simpler. The problem with factoring is not every problem can be factored. Every problem can be solved using the quadratic formula. So factoring is nice when it can be factored, but if it can't, then you need to use quadratic formula for these. Now let's think about our discriminant. The discriminant is the value underneath the radical. That is our b squared minus 4ac term. And that ended up being this 169 in here. So 169 was our discriminant. Now if you go back to the rules, because 169 is a positive number, that means we ended up with two real roots. And our real roots were positive 11 and negative 2. All right, so let's take a look at the next one. Let's see if we can do this by factoring. If you take 0, put it in for the y value, and that equals 2x squared plus x minus 3. 2x times x is the only way to get 2x squared. 3 and 1 is the only way to get 3. This is going to be a positive and a negative. You can use box method to factor this as well. I'm not going to go through that time. We've already covered that before. All right, so we have this term times this parenthesis. The value of x that makes the first parenthesis equal to 0, well, you can think about subtracting 3 and then dividing by 2 would give you a negative 3 over 2. And on the other one, x minus 1, if you put that equal to 0 and solve, that would give you x equals 1. So we do have two real answers. This is a factorable problem. And if we think about using quadratic formula down here, the a value is 2, the b value is 1, and the c value is negative 3. So as I mentioned before, what I want you to do is come through and make a template for inserting all of your a's, b's, and c's. And we're going to insert those values now. All right, so negative b, that's 1. B squared is 1 squared. 4a, which is 2, times c is negative 3 over 2 times the a value of 2. Then we come back and simplify this, giving us negative 1 plus or minus square root of 1. And then negative 4 times positive 2 is negative 8. Negative 8 times negative 3 is positive 24. All of this is over 4, giving us negative 1 plus or minus the square root of 25, which is negative 1 plus or minus 5. There's no more radicals, so we can get our two answers. Negative 1 plus 5 is 4. Divided by 4 is 1. Negative 1 minus 5 is negative 6 over 4, which negative 6 over 4 reduces to negative 3 over 2. So we end up with the same answers that we had right up here. Now let's go back to our discriminant for a second. The discriminant is the b squared minus 4ac, which is the value underneath your radical here. So b squared minus 4ac in this case was a positive 25. It is a positive number, which means we had 2 real roots, as you can see here and here, 2 real roots. If we had 0, there would be 1 real root, and if it was a negative number, then we would have imaginary roots. So our answer would have the i's in them. All right, so if you look at the next problem, if we try to factor this, you would find out that this particular problem is not factorable. So since it is not factorable, what we're going to do is use quadratic formula. All right, so quadratic formula, A is 3, B is 2, C is 4. Let's go ahead and think about our discriminant so we can think about the answers that we're going to end up with. Your discriminant is b squared minus 4ac. That would be 2 squared minus 4 times 3 times 4. Well, that's going to give us 4 minus 48, which is a negative 44. Since this is a negative 44, that means we are going to end up with 2 non-real complex roots. Our answer is going to end up with i's in them. All right, so let's go ahead and make our template here. Insert our values, B, B, A, C, and then A. And then number crunch this thing to simplify it. Negative 2 plus or minus square root of 4 minus 48 over 6, which is negative 2 plus or minus square root of negative 44 over 6. The negative on this will come out as I because the square root of negative 1 is I. So we can go ahead and do that right away. And then if you simplify the radical 44, that's 4 times 11, which is 2 times 2 times 11. You got a pair of 2's that will come out. This becomes negative 2 plus or minus 2i square root of 11 over 6. Now what you want to look at are this term, and this term. If all 3 terms have something in common that they can be divided by, then you need to go ahead and divide by that value in order to simplify this. All 3 of these are divisible by 2, so that's going to give us negative 1 plus or minus 1i square root of 11 over 3. That will be your simplified answer. So let's think about this simplifying thing. If you take 4 plus or minus square root of 32 over 2, well, 32 is 2 times 16, which is 2 times 2 times 8, and 8 is 3 2's multiplied together. All right, well, you got 2 pairs of 2's, so this ends up being 4 plus or minus 4 square root of 2 over 2. Well, this number, and this number are all divisible by 2, so that would give us 2 plus or minus 2 square root of 2 over 1, which we don't really need. And so this ends up being your simplified answer. All right, now the next one, if you just want to move the negative out, that becomes an I, because the square root of -1. And then simplify from there. Well, 72 is 9 times 8. Well, that's 3 times 3, and then 3 2's multiplied together. So you got a pair of 3's and a pair of 2's that will come out as a 6. You already have the I. You have a 2 left over 6. All right, so 3, 6, and 6 are all divisible by 3. This becomes 1 plus or minus 2i root 2 over 2. That is your simplified answer. Now on this one, the square root of 100 comes out evenly to be just 10. We have no more radical, so like I mentioned before, when you have no more radical, you need to go ahead and find your two answers. 1 plus 10 is 11 over 2, and 1 minus 10 is -9 over 2.